forces of 20 newtons at 105 degrees, 70 newtons at 215 degrees, 40 newtons at 30 degrees, and whatever force you're exerting combine to give a 30 kilogram object acceleration 2 meters per second squared I, excuse me, plus 5 meters per second squared J. So, what's the force you exert? Well, first thing to do is write these forces in terms of their components, and that's very straightforward. You just multiply the force by the sine or cosine of the angle, depending, and we get these results, and then your force we'll just call F sub 4x, F sub 4y, x and y components, so that the sum of the forces is negative 28 newtons plus F sub 4x minus 1 newton plus F sub 4y. All very straightforward. But the one thing that you might not occur, obviously this is going to occur, I think, to everybody very quickly, but then we represent the force that you exert, and you can use other notation for that force. You don't have to use F4x and F4y for the components, but whatever variables you want to let represent the x and the y components of that force are fine. Anyhow, okay, so in this case now, here's the sum of our forces. So our net force expressed in the IJ notation is just the x component multiplied by the I vector plus the y component multiplied by the j vector. Also, of course, the net force is equal to the mass times the acceleration, and we're given the acceleration and the mass. So we can actually figure out exactly what the components of the net force are, and that's going to then make it very easy for us to figure out what the components of your force need to be. So, simple multiplication of the mass by the acceleration vector tells us that the net force 60 newton times I plus 150 newtons times J, so that the I component of F net, of course, has to equal the I component of F net. And we have two different expressions, 60 newtons times I and negative 28 newtons plus F4x times I. Those have to be equal so that negative 28 newtons plus F4x is 60 newtons. And we very quickly conclude that F4 is, in fact, 88 newtons. And fairly careless this morning the way I wrote things. No, there's nothing wrong with that. Okay, thought I'd made a mistake and hadn't. I saw the arrow over this. I thought this was still referring to this up here, the component, but this is the force. So the force F4 is going to have an x component of 88 newtons, and that follows immediately from this equation here. And then similarly, 150 newtons is the negative 1 newton plus F4y, so that should be negative there, and it's negative here. Okay, so our F4y, okay, setting this equal to 150 newtons, solving for F4y would very easily get 151 newtons, so that the j component of our F4 vector is 151 newtons. We can also calculate the magnitude of F4 using the Pythagorean theorem. Very simple. We get approximately 170 newtons, and the angle, arctangent, 151 newtons over 88 newtons. It's going to be about 59 degrees.